Before I begin, has anyone actually seen a talk given by any of the SHMU group members? Because they say and do something that I seriously believe in. They go on this huge rant, they have a whole slide on it. I don't. That basically says, don't believe a single thing that I say. Just because I'm up here talking doesn't mean I'm right. It's designed to encourage people to go out and play with it and learn it on their own. And I fully believe in that. So don't believe a single thing I say ever. Validate it yourself. So hopefully you learn something in the process. Has anyone here actually used FreeBSD on a daily basis? I figured you would with the OpenBSD shirt. I figured you'd know about it.
FreeBSD is awesome.
There's another one. Okay, so I'm not alone at a FreeBSD user at a conference sponsored by Fedora. But I fully support, use whatever OS you want. I don't really care. Whatever floats your boat in this regard. So for me, it happens to be FreeBSD, and that's what I like. Speaking of me, formally, my official title that I get paid to hold is a Senior Information Security Scientist / Engineer. We're not going to talk about my previous title because you'll probably beat me down for it. Informally, when I'm not at work and actually do a lot of this stuff at work, I'm a FreeBSD user. I'm a FreeBSD contributor, which is not a committer. I do not have a commitment. I'm not associated with the project in any way besides using it and submitting patches, mostly for the forestry. I like to hack on things. I like to explore operating systems and OS design. And I'm a member of a couple different groups, Ghetto Hackers, x90.org, and a couple others. So what are we going to be talking about today? Today we're going to be talking, I'll cover the prerequisites, a couple basic OS design concepts, and a very basic Unix access model concept. Then we'll discuss process isolation, what it is, what it means, how things are isolated, how they're not. When I say things, I mean processes. The historical solution to process isolation and why it's just not good enough. And then that will lead into why it's not good enough. You can then figure out from there where we're going. We're going to discuss jails from a very high level. And then I'll dive right into the details. Believe it or not, they're really not that complicated. And then I'll explain how it relates to other things in this space. And then we'll cover some interesting future work, and I'll give a brief demo. The demo is kind of, I'll just do it by the seat of my pants. I don't really have anything planned. All right, so prereqs. If anybody's ever looked at an OS in any design fashion, this is pretty standard stuff. You got your layer of hardware. On top of it sits your kernel, which manages your hardware. On top of your kernel sits your user land, and the boundary between these two is through syscalls. And then on part of the user land is your processes. I put them on top just because it made more logical sense. It's very standard stuff. This should be no-brainer to most people. So the other prereq is access checks. In Unix, for traditional Unix model, there's mandatory access control and role-based access control and all these other things. But normal, it's root and everyone else. And if you're root, it doesn't matter what you do. You just granted access. And everyone else must pass checks. This is where things like file permissions come in, group ownership, that kind of stuff. So keeping those two things in mind, the problem is if you're root and you have a process running as root, it's not isolated from anything, short of memory space, and we'll talk about that in a bit. But if you give somebody root on the box, I don't even give my friends who I trust root on my box. I don't even give my own brother root on my boxes, okay? So
I would not have been dirty.
What if somebody says, hey, here's a binary that I want you to run, oh, and by the way, run it as root? I mean,
oh, sure.
Trust me, it happens, people do it, people will try to get you to do it. It's a really stupid thing to do, but there's a whole list of reasons why you may or may not want to use jails, and maybe they will become apparent at the end here. So the answer to the problem of isolation, and the meat of this talk, is jails. They've been called poor man's virtualization. I seriously hesitate to use the term virtualization, which hopefully by the end of the talk will make sense, because you're not really virtualizing anything. It's purely isolation. But before we can go any further, you need to define isolation and define how things can and cannot be isolated under the normal model without jails. And then the history of how their jails can to be, so to speak. Process isolation 101. There's virtual memory provides memory isolation. You have a process, it writes to a chunk of memory it doesn't have permission to write to. It segfaults, it core dumps, it dies in some horrible, painful death. Or it crashes or it otherwise misbehaves. It's contained to its own virtual memory space. That's a good thing. This is by design. So one process cannot just randomly start arbitrarily writing to memory and screwing things over. With exceptions, because there's like dev cavemen and stuff. But for the most part, you have virtual memory space. And that's good. The downside is you only have virtual memory to work with. Processes can still, send signals to other processes. You still have IPC calls. You've got, it can just start calling kill. Why not? There's tons of different ways for processes to affect other processes on any given system at any given time, provided they have the right permissions. So like you got a misbehaving root process running as root. What's really stopping it from sending the kill signal to, I don't know, your mail server, your Apache server, or init, whatever. Okay, so does everybody get process isolation at this point? Really only have virtual memory to work with here. So traditionally, people have said, oh, well, we'll just chroot, chroot, whatever you want to call it. I'll stick with chroot. You can just chroot your process into a given piece of your file system, and it can no longer write outside of that piece. So you have like, user chroot space and a file system under there. You chroot it into user chroot space. Its concept of the root node is that directory. It cannot get any higher. There have been ways in the past to break out of it, but it's been refined over time. Believe it or not, chroot was actually written by Bill Joy many, many years ago, and I mean many, solely for the purpose of letting him build whatever BSD tree he was working on at the time. I think it was BSD tree, I might be wrong. To let him build it in a completely clean environment. So he would chroot into the source tree and start building. That way he wouldn't have to deal with the already installed libraries or anything like that. Then along came anonymous FTP, and people said, well, holy crap, we'll use chroot to chroot in the anonymous FTP session. And then people broke out of chroot, and that's how it kind of got its bad name. But over time, it's been refined. Most attacks against chroot are covered. So it's pretty good. It's got a bad rep, but it's pretty good. It does the job for limiting file system access. So what? So now you have virtual memory space covered. You've got your file system covered as far as isolation goes. You've still got signals to deal with. You've still got network access. Processes can still do just about anything besides dealing with file system that it shouldn't and virtual memory that it shouldn't. So you need something else to address these. That's where jails come in. Jails basically kind of like virtualization without the virtualization, if that makes any sense. You have one piece of hardware, again, your single box, and you have one kernel, but you can have multiple copies of your user land running on top of that, and your kernel is going to enforce isolation between them, such that these two processes only know about each other, and these two processes only know about each other. This process can't send a signal to this one can't send a signal to that one. The kernel is going to enforce its isolation. That's the goal, right? Yeah?
That sounds a lot like user mode Linux.
It very well might be. I'm a BSD guy. I don't pay much attention to Linux. My understanding of user mode Linux is you're going to run a kernel with userland on top of it,
Okay.
which is entirely different. It's like Dragonfly BSD's virtual kernels. So you have a kernel running in userland with another userland on top of it, maybe? I don't know. I don't know how it works, but it's not entirely the same because user mode Linux, you really are running a kernel as a process. So this one is not. You just have your separate userland and your kernel is doing your isolation, your one kernel. And I have a similar slide later that explains the relation to virtual machines and stuff. Sorry. So, okay, so jails in a nutshell, right? For all intents and purposes, think of it as a virtual machine, right? Processes are assigned a given jail identifier. That That jail identifier is inherited by the children processes, I guess. So that, if you start init in a jail, or SERC or whatever, and it's going to spawn off all of your daemons or all of your shells or all of the processes that you need in that jail, all of those jails get that jail identifier. And anything they exec is going to get that jail identifier. That jail identifier is used in access checks.
So I still need separate processes for each of those. I can't have one init or one Apache and have it.
Correct. If you have Apache in jail,
as
it's
their
a completely separate process from Apache in a different jail or Apache on the host.
So I need multiple instances for each.
Of each process, yes. That jail identifier is used in access checks such that process A in jail 1 cannot talk to process the same actual process in jail 2. Actions are restricted, and I'll explain that later. The basic concept is, you can't do anything that's going to modify the host system. You can't, change the routing table. You don't get raw network access or raw socket access, that kind of stuff. And privilege is granted based on the jail identifier, meaning root in the host OS gets access to every jail, every process, because UID 0 and jail ID 0, meaning the host OS, is the true root. UID 0 in a jail is really just root in a jail, and they have no access to anything outside of that jail. Okay, now that's kind of the high level piece of jails. We'll cover the technical piece now. I'll try to stay away from showing a whole lot of C code and stuff. That's why I read it. Okay. There's multiple pieces. You have your userland piece, that's jail 8. 8 being the section of the manual page it came from. I forget exactly what it stands for. You can go read the man page if you really care. Jail 2 is your syscall. Jail attached to is your other syscall that is used in jails. And then the other piece that makes it all work is the restrictions, the piece that is enforcing the isolation in the current. And there's a lot of it. Okay, this is going to maybe confuse people. So the basic flow of jail. You're up in userland, doing your business, you want to start a jail. So you're going to call jail 8 and give it a bunch of arguments, which I'll explain in a bit. Those arguments are going to be set in a structure in memory and passed into the kernel via the jail 2 syscall. The jail 2 syscall is going to manipulate those that data that you passed in and find an in-kernel memory structure called the prison. And it's basically a linked list of prisons. And it will walk that linked list till it finds one. And if it doesn't, it will find a matching one, I should say, based upon the data you gave it. If it doesn't find it, it's going to create a new one in that linked list. And that prison structure is a list of all of the running jails. After it creates that structure, it calls jail attached to, which takes the process that you started this whole thing with and attaches it to the jail that it just created. Control is then given back to jail 8, and jail 8 then goes and execs whatever it needs. So at this point, right here, you have a process running in the jail because it's been attached. So whatever you're going to exec must live in the file system of the jail. So, I mean, if you don't have a bin.sh in the jail and you want to exec bin.sh, not going to work. Okay, so when you're using jail 8, this came straight from the man page, the bin pieces you're going to want are obviously the path, the host name, and the IP number, the IP address, and the command. The path is a piece of the file system that you set aside strictly for this jail. It's either a full userland or a minimal userland or just a given binary in the libraries it needs. It's really whatever you want to set up in the jail. For what I do, for what I use jails for, it's always a full userland. The host name, it's again just a host name that your jail will identify itself as. The IP number, IP address, it's just an alias that you set on the NIC. And the command is the command that it will exec after the jail has been created. There are lots of different arguments that you can use. Play with them. That's the best I can tell you. I don't really use them all that often, but they're there if you really want. They're very flexible. So when you call jail 8 and you give it the path, the host name, the IP number, IP address, and command. I don't know why they use IP number and command page. It's going to set all of those, the path, the host name, and the IP number, in a structure. This was the structure I was telling you it sets up in memory. The version, it's just, so you can say, oh, well, we've changed the way jail works. We're going to increment the version number in this structure, so you can tell particular versions apart. But it sets up those structures and passes them in to jail 2. There you go. Calls the appropriate structs, passes them into jail 2. Yeah?
Are you limited to one IP?
In a jail currently, yes, there are patches out there for them, but they haven't been committed yet. But right now you get one IP. So it's going to call jail 2 and then let jail 2 do its thing and then eventually exec out the program it needs. So what does jail 2 do? There's the prototype for jail 2, the definition if you really care. Jail 2 ultimately is going to return a non-negative integer. In the case that it returns a negative integer, it's errored and it will set error number accordingly. That non-negative integer is the jail identifier that it has created or already found in the prison linked list structure for you. The full-on details of jail 2 internally, you got to remember jail 2 is running in the kernel at this point. It's a syscall. It allocates that prison structure I was telling you about, sets the values in based upon the structure that you passed into it. It increases the reference count of the prison. This is probably one of the most important pieces that it does. The fork and all the process creation calls have all been modified such that if they're running inside of the jail, they will increment the reference count of that particular prison in the kernel. And anytime a process is destroyed or dead or killed or gone, it decrements that reference counter. If that reference counter ever hits 0, the jail is removed from the linked list in the kernel. You no longer have a jail running with that jail ID. That's how you can keep track of jails starting and stopping inside the kernel, is just by using the reference counter. It's common. Object-oriented languages tend to do it. If object A is referencing object B and object C is referencing object B and object A goes away, you know you have to keep B alive because something is still referencing it. It's a very common thing. That same structure is attached to all calling processes, or attached to the calling process inherited by all children, like I said, and goes and calls jail attached to. That's the prototype of jail attached to. It's really simple. Its whole goal is to find the right prison in the list, because the list has already been populated with your jail ID. Assess the route, the file system route of the current process to that of the prison. This is useful if you know you have a jail already existing, and you want to, there's a command called jexec, you want to exec something into a jail. You don't actually have to call jail 2 because you know it exists. You can just call jail attached to and bypass that whole jail 2 system. So the end result after jail attached to is control is passed all the way back up to jail 8, and you can then exec whatever you need into the jail. So the end result is you've got something, whatever command you gave it, running in a jail. Usually it's a shell, could be Apache, could be an FTP server, whatever you want. You keep it in the jail. This is the very bottom piece of the overview slide that talked about access restrictions, or I forget what I called it, but there's a lot of them. But the basic principle is unless specifically allowed, actions inside of the jail are automatically denied. This is important because anything new added, not allowed in the jail unless it's audited to be declared jail safe. It's what allows the system to keep growing without having to go back and say, oh, well, how does this affect jails? If you want it to be in a jail, look at it and specifically enable it for jails.
Is that through reads as well on your file system?
Reading, you got to remember, it's basically Chroot on steroids. So you've Chrooted it into a piece of the file system, so it can read whatever file system you access or you tell it to. whatever file system it's been rooted into, or file hierarchy.
And also write to it? I mean, like,
Absolutely,
overwrite
it's a
file.
full process.
So,
Think of it as a virtual machine. It's, if you have a process running in a jail as root, it's got full access to the file system that it's rooted into. Just think of it literally as a regular machine. It's a step between regular discretionary access controls on a full-blown host system and SE Linux or whatever mandatory access control system you want to put in place without having the pain of dealing with SE Linux or anything. Does anyone here use SE Linux? I imagine you do because it comes with Fedora, right? Yeah, I think it does. Does anybody actually use it on a day-to-day basis? Yes? Is it a pain in the ass?
Yeah.
Yeah, I use it on a daily basis. Pain in the ass. But it serves its purpose. It's not a bad thing. It serves its purpose. But it's a pain to administer and control because there is so much going on that you have to deal with. Okay, so the basic rule of thumb for jails, if it's going to modify the host system in any way, i.e. a routing table, loading kernel modules, unloading kernel modules, mounting, unmounting file systems, creating device nodes, setting syscontrol stuff, I don't know, maybe accessing processes outside of the jail, it's denied. Because you're supposed to isolate jails not only from each other, but from the host. And changing security flags in a jail, again, not allowed. So what can you do in a jail? Treat it as a regular OS, really, if you have a fully populated user line. It's, you get one IP address in your jail for now. There are patches out there. I haven't actually run them, but I've been told they're pretty good. You get full-on process control. You can send signals within a jail, no problem. You can issue PS commands. You can issue kill commands, top, all that works. Inside the jail, it all works, no problem. You can set resource limits to a degree. The scheduler is not jail aware. It's in the works. It has been for a while now. But when I say resource limits, I mean things in like login.conf that set memory size of a process, those type of resource limits. The other thing you can do is manipulate in-jail things from outside of the jail. Jails are designed to isolate jails from each other and jails from the host system. The host system has full access to the jail, provided it meets the requirements. Like root in the host system can just start killing off processes in the jail if they want. It's just the way it works. You can also bind a reserved ports on the jail address from within the jail, just, provided you meet the requirements. You got to be root to bind a less than 10.4. You can also bind to, has anyone written any C code that uses the inadd or any macro, or definition, whatever it is? It's designed to say, I want to bind to every IP address, this port on every IP address on the system. Inside a jail, if you make that call and you use the inadd definition, I guess it's called, that will be translated to just the IP address of the jail. So it's a way to, most C code, I've never seen anything that doesn't run in a jail that is using inadd or any. That way you don't really have to port something to be jail aware, it just works.
well, what about some applications that require like a loopback to transfer things between them? I've seen like say.
Those will probably have to be modified. Yeah, they probably have to be modified. I don't know of many that do that, but I'm sure they do exist. You probably have to try them. The other thing that will not work is, like I said, you don't get shared memory access. So Postgres in a jail doesn't work. It uses shared memory. However, if you really need Postgres in a jail, you can turn it on. A lot of these things that are turned off by default can be turned on. Some of them, like shared memory, if you really want. So, you can. Yeah.
What's the deal with the raw packets? Why aren't those available?
Why
Like you can't run ping in a jail, can you?
You cannot run ping in a jail, correct.
And also, I noticed in the 4.x versions, as a regular user, non-root in a jail, you can't run top either.
It's been fixed. I haven't run 4x in years, but
But
I know you can now.
Is the raw packets denied for security reasons, or is it a difficulty with implementing that in the kernel?
My guess would be security reasons, though what they are, I'm I'm not entirely sure, but raw socket access is denied. My guess,
Well, think about it. If you have raw access, you can just start setting IP address to anything. I mean,
yeah, you could probably just start spoofing things that you shouldn't be allowed to do. It's probably an isolation security issue. But the exact specific reason, I don't know. And the interesting future work that I'm going into in a few slides will hopefully, clear up things that they're doing to address some of these problems. Okay, like I said, outside the inside manipulation of a jail is a problem. I'll show you it in a demo. It's really not that hard. But if you give somebody root in a jail and just regular user access outside of the jail, you really might as well give them root to the host OS because nothing is stopping them from making a copy of bin.sh, changing it to be SUID root, and then from their host account, which is non-privileged, just running it because it's sitting on the file system of the host OS. Nothing is stopping them from running it, and I'll show it. Sure, you could technically mount the jail partition, like put it on its own partition and mount it as no SUID, but then things inside the jail like SU stop working, or other things that need to be SUID stop working. So, I mean, it's really designed to keep things inside the jail inside, things from outside the jail. If you got regular user access, you got the ability to start doing things inside the jail, because if you have root inside the jail. There are no scheduling abilities. It's in the works. The scheduler is not jail aware, so you can't say jail 1 gets 50%, jail 2 and 3 get the remaining 50% split between them, 25 each. Can't say things like that yet, though it's in the works.
Couldn't you use like regular VSD accounting based on usernames, things like that, to do scheduling, like UIDs and whatnot?
Sure.
Finite.
That's going to turn into a maintenance nightmare. Let's say you have 50 jails with 50 Apache processes running, and you'd have to run each of them under their own UID from the host perspective, which you could do, but it's not going to be fun. So, but it could be done. Yeah.
Just an aside, one way to mitigate that, or maybe do something similar, is with the login.conf, where you can do memory limitation and...
That's all allowed by default. You can still do things like that.
But that might be another way to accomplish the same goal.
Possibly. One thing that the mailing lists have been discussing have been, and this was a while ago, was the concept of a scheduler running inside of a jail, which schedules jail only, processes only for that jail, and the host scheduler can just schedule that like a regular process. It's probably not exactly optimal, but it's an avenue to explore, and the code's out there, and you can go play with it if you want. And this thing, the bottom bullet here, running a current world in a 5x jail, it's a bad idea. Running a 6 world in a 4 jail is a bad idea. This would be like the equivalent of running, here's where I show my complete lack of Linux knowledge, running a particular binary that's expecting a 2.6 kernel, running it in a jail that's running on a 2.4 kernel. That's just, it's always a bad idea. So if you're running 6.2 world in a 6.2 kernel, run 6.2 jails for the most part. You can probably get away with like 6.1 or something, but you definitely don't want to run 5, and you don't want to run 4, and you don't want to run current. Major version hops are bad ideas. Okay, so the alternatives that I have talked about here, you have your standard fine-grained access control things, SE Linux, Trusted BSD. Solaris now has all kinds of different mandatory access controls and role-based access controls and all of these. You have systrace for OpenBSD. I think maybe NetBSD has systrace. Does anybody actually know? I don't. So you have those options, which are, in my opinion, useful, a huge, huge pain if you have any type of a dynamic system where you're loading new apps or touching files all the time. It's a huge pain. Your other option is machine emulators like VMware Parallels, QEMU, Box, all of those, which are great, but they also come with problems. Like I said earlier, fine-grained access control, huge, 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 huge pain in the butt for day-to-day use. If you're going to stand up one box that has a handful of services, tweak your SE Linux or your whatever mandatory access control policy, tweak it for that install, stand it up, let it run. It'll run like a champ, it'll do its job, you know, it'll enforce all kinds of stuff for you. But if you want to stand up a new service, now you got to retweak your policy. It's a huge pain in the ass for any type of development work or anything like that. So I don't recommend it for, you know, just day-to-day use. You're going to end up hating it more than you love it. But it's great for, you know, standing up production boxes or something. The problem with VMs is they can be memory and processor intensive. I have a machine in my work. It's like 2 terabytes of disk, 8 cores at like 3 gigahertz, and like 32 gigs of RAM. And it serves something like 60-something VMs without a problem. I don't know anybody who has that kind of money except for it at work. So there's, you know, if you want to do serious amounts of virtualization, you need to pay serious amounts of money. VMware is not cheap, and the hardware to do it properly is not cheap. But it is getting better. This laptop here has got, it's an Intel dual core, and it's got the, what do they call it, VT extensions, the hardware assisted virtualization or whatever. AMD's got a chip out with it, a bunch of chips out with it too. This thing runs like half a dozen VMs, and I can't even tell. Like, no performance hit whatsoever. So it's good for that, but you know, as time gets on, VMs are becoming less and less intensive, but they're still VMs. They're full on things.
Are you running VMware on that?
Parallels.
Oh.
Yeah, it's a MacBook. So
Well, there's Mac.
yeah, but I said screwing Mac Parallels.
Does the jail run on the Apple modified BSD kernel?
I'm going to go out on a limb here and say, oh hell no, because it's not a FreeBSD kernel running in there. There are pieces of FreeBSD running sort of in the kernel, sort of not. Like, I'm not entirely sure. I haven't dove into Darwin or whatever you want to call it. It's running under there. But my understanding is you get things like its virtual memory system. Part of its VFS cache is FreeBSD. Its networking stack is FreeBSD based, but the actual kernel is very little FreeBSD in it. And some of the user land pieces are FreeBSD too.
What, isn't the mock kernel?
It's a mock kernel, exactly. And it's, you know, it's sudo next step, sudo mock, sudo xnu kernel. I don't know what the hell it is, but it's, no, jails are not designed to run on OS 10. As far as I know, they're only FreeBSD. NetBSD hasn't implemented them. OpenBSD hasn't implemented them. Linux hasn't implemented anything like it. They're going their own like user mode Linux approach, or SE Linux. So, you know, I'm a full proponent of use whatever the hell you want. I don't care. So when we're talking emulation being memory and processor intensive, which they are, but they're getting better. The problem with them, or actually it's a benefit, not a problem, is so you've got your hardware, your kernel, your virtual machine monitor or emulator piece that is maybe not running in the kernel, depending upon what particular VM software you're using, is that it's actually emulating hardware. You know, if you want to say, what the hell, I want to add another disk. Tell your VMM to emulate another disk, or emulate another NIC, or emulate 50,000 serial ports, you know, provided you have the resources. What the hell, why not? It can just start adding hardware to your virtual machine, no problem. That's great if you need to do something like that. And I use it all the time when I use VMware Parallels. I'm like, well, I need 3 NICs. Well, what the hell? Just start adding NICs. In jails, you don't get that because you're not actually virtualizing any hardware. You're just isolating things from each other. So if you have only 1 NIC and you need 2 or 3 physical NICs for something, you're more or less SOL unless you add physical NICs to the box. But then you're limited by the 1 IP address in the jail problem. So.
What about like copy on write with the memory? So say you're running 50 versions of Apache. Is it going to take one version of Apache and then run it 50 times with the copy on write or something in jail, or because I know VMware does that in certain respects, where they'll find large pieces of memory that are the same and just do a copy on write on there so that something changes.
It might, I don't know, but that would not be jail specific, right? Because what is actually doing the executing of that process or the running of that process is in the kernel. You've only got 1 kernel, so if it notices, hey look, I've already got this process fired up and in a relatively clean state, I'll just grab a copy of it and use it for now, and when it changes, I'll write out a new one. That wouldn't really be jail specific. It may or may not do it. I haven't really looked at that. So like I said, with emulation you can change the hardware and it's great for that, you know, but at the same time, jails are far, far less resource intensive. You can just have an ass ton of jails. And I know Al knows what an ass ton is now, of jails running. And almost no overhead. If you run no jails, there is no overhead. For, you know, all intents and purposes, there is no overhead. So the interesting future work, I'll let this sink in for a bit because there's a lot of really cool stuff. So the piece that they're going with is, which I absolutely want to see. I'm waiting and waiting and waiting. I want to see it so bad. The network stack virtualization. Right now you get one stack and it's shared between all of your jails with an IP alias. Network stack virtualization. So you can say, I've got a stack that needs to be running IPX in this jail. Give it the stack. Or I've got a stack that doesn't need to be running IPX in this jail. Here's a stack without IPX. I want a stack that's running PF. Give it a stack with PF. I want a stack that's running IPFW. Give it a stack, you know, practically endless network stack virtualization things that you can do. You can actually get BPF interfaces in a jail with network stack virtualization. Right now, if you want to sniff in a jail, not allowed. You don't get a dev BPF node because for obvious reasons, there's only one stack. You'd be sniffing things you shouldn't be allowed to see. Per jail firewalls, like I said, the way firewalling works right now with jails is you do your firewalling at the host level. So if you have, you know, jail 1, 2, and 3, whose IP addresses are 1, 2, and 3, you know, 1.1.1 and 1.1.1.2, etc. You could set up rules that say, drop everything unless it's destined to port 80 on 1.1, or if it's port 22 on 1.2, or if it's port 25 on 1.3. But you're doing that from the host level. The jail administrator has zero access over that firewall rules because they don't get a real network stack to play with. There's patches out there for multiple IP addresses in the jail. Could be pretty cool, might be neat. There's a push to make a jail-aware scheduler. Solaris 10 has almost all of these things. If anybody's not played with Solaris 10, holy crap, it's awesome. And one piece that just hit the tree about 3 weeks ago is something called jail services, and I haven't had much of a time to look at it. But my understanding of it is that you can have certain pieces of your kernel register as, hey, I'm a service. If a jail needs me, load me up and get me to a jail. So you could have, like, you know, file systems say that. So you could start mounting and unmounting file systems from a jail. I think. I'm not entirely sure. Go read the code if you really care. All right. So this is where I do the demo piece. All right, let me turn this back to mirror mode, I guess. Is it all right if I turn this thing off so I can keep typing?
Yeah.
Yes?
Yeah.
Okay. All right. I probably should have had this VM fired up already, but I don't. Sorry. Can everybody see that? Okay. It's just a FreeBSD 6.2 jail, or not jail, sorry, VM running in parallels. Let it boot. And while I was setting up this demo, I actually did make sure I knew how to start jails and everything. Does anybody catch that? It actually says about half a dozen lines up, starting jails, test, and test 2. I actually have 2 jails running on this guy. I'll show them to you. But first, don't look at that. It's my notes. Okay. Please don't look at that. I don't care. It's just my notes, so I know what I want to cover. So right now I'm in the host OS. It's just called demo. Syscontrol security.jail. Oops. Right, so there's a bunch of different syscontrol settings that you can set. These are to kind of like knobs for tweaking a running kernel in FreeBSD. And that's the default state of them. The bottom one is what's probably important right now, is security.jail.jail syscontrol is set to 0, meaning you're not in a jail. You must be on the host OS. So the first thing we're going to do, there's a command called JLS, quite literally jail listing. Gives you all kinds of information about it. There might even be a verbose flag, apparently not. Gives you the jail ID, the IP address of the jail, the host name, and the path to said jail. You can look at the mount points. It doesn't actually mount those paths at all. They're just a piece of your already mounted file system that it's going to shroud into. But what it does give, based upon the way I set it up, you can turn this on or off, is it will mount debfs into the jail so that you can get like PTY nodes, that kind of things. So to build a jail, you pretty much need a file system to shroud into. I always just use fully populated FreeBSD world. You don't really have to. You could just put Apache and whatever libraries it needs in there and just shroud into that and let that run in the jail, no problem. But what I'll do here, actually, need to give it a directory user, jails, I don't know, CarolinaCon. Make install world tester equals user jails CarolinaCon. This will take a couple minutes. It's just going to build or install the entire world in there. Well, that's running. Any questions? Or we can just sit here and watch it scroll by.
Do you use SE Linux in Red Hat Enterprise or in something like Fedora?
Red Hat Enterprise.
Have you used the configuration utilities that are in RHEL 5?
No, I actually inherited a couple SE Linux boxes and said, what the hell? And in the process of ripping them out.
Yeah, in 5 they make it a lot less of a headache.
Like I said, SE Linux is definitely good for many things. What are you guys pointing at? Okay, it's good for many things, and it's definitely getting better from an administration standpoint.
Yeah.
But for my needs, my day-to-day work needs, and my day-to-day development needs in my personal life, I don't touch Linux at all in my personal life. So. But you know, if SE Linux floats your boat, what the hell, go for it.
Is this a canned thing that you're running there, or is that a script that you wrote that grabs all the things you want to move?
This is, if you go into the user source directory or wherever your source tree lives in FreeBSD world, there's a bunch of different make targets in there. Install world quite literally takes the world that it has already built. Like I already have a world pre-built here that I've used before, and it just installs it into whatever directory you tell it to. By default, that directory is /. So
Tweak that and then use...
You don't have to tweak it. It actually accepts a dester argument.
Oh, okay.
If you see it here, you don't want to see the bottom part. The make install world dester equals. I just gave it the path, you know, the directory I just created, user jails cc. Should only take maybe another minute or two. We're already on the man pages.
And then if I want to change what that install world is slightly, the
You can just
install
start-
world is a script that...
It's a target that it installs the entire world, but nothing is stopping you from just copying over the binaries you want if you want, you know, just a handful of binaries.
It's a make script, right?
Yeah, it's a make target. That's all it is. Almost there. Are there any other?
But the concept of the copying over the binaries, right?
Yeah, this is the same concept. If I really wanted a minimal install, I can just copy over, you know, a handful of binaries that I want in the jail and use them. But since I do, what I mostly use jails
But I
for.
was getting at like somewhere in between. You would make us your own make file if you were going to do this a whole bunch of time with some
Yeah, write
specific
your own
thing.
script that copies over whatever you need for whatever jailing purposes you want. Absolutely. Or just build a small world. Like I built the full world. You don't have to. You can build a small world if you want. And just use the install world target to install just whatever you build.
What about also like making something with statically linked libraries and then installing it? Or doing
That
it
one
install?
binary that's statically linked, sure, you can do something like that. And people do that a lot. If you haven't caught on by now, these are great for like web hosting things or shell providers, or you know, where you have possibly untrusted users running who knows what service, and you have client A who needs like PHP 3 from like 1980, You have client, 2 who only needs PHP 5 and that's it, or client 1 wants Postgres and client 2 wants MySQL, and you want to keep them isolated from each other such that the vulnerability from, the hundreds of vulnerabilities over the last 10 years of PHP 3 will not affect this other guy who's using mod Perl only. It's great for that kind of setup. So the last command is installing your /etc directory. This goes by real quick. User jail cc. This sets up your password files and Etsy group and the things that live in Etsy usually. And for kits, we'll do a mount-t /. User jail cc. Right, so now I have a devfs. I'm sorry, I screwed that up. User jail cc. We want to mount devfs into /dev. That's important. So the other piece, when you're calling the JLA command, you needed a host name, a path, an IP address, and a command. Right now we have the path. We'll just assign some random arbitrary host name, doesn't matter, and a IP address we need. So we're going to give it 10.211.55.102 will work. Config ed0 alias 10.211.55.103. Right, so now you can see 10.211.55.9 is the IP address assigned by the DHCP server running on this laptop here that the VM is using. And the other 3 are the IP addresses that I've set for jails, 103 being the most recent one. I don't know why I typed 103. I meant to type 102. It doesn't matter. So you want to run something in a jail, not a problem. Use the jail8 command. User jail cc. Give it a host name of cc. 211.55.103/bin/sh. We'll run bin/sh inside a jail. Security.jail. Look at that. Security.jail.jail